Sorry. Okay, here we go. We have a programming environment established, and if you haven't used Rust before, it is a compiled language. So the biggest, so down the bottom I have a terminal, and up the top I've got an editor. Now to compile this, I've got this kind of little tool called Cargo, and it is running my stuff. Now the first question we want to establish is, like, what is an object? And this is a harder question to answer than you may maybe experience, but I'm going to give it a go. So one of the first things about an object-oriented language is that you get something that looks a lot like I'm just going to write Python here because I know Python most, and if I write something like a class definition and I've got like a rectangle, I might have like an init method which takes another like x and y, and self.x is x and self.y. I'm ignoring the fact for the moment that a recent version of Python has introduced data classes, which actually simplifies the syntax a lot. But like, how do I do this? So question one. Question correctly. How do I emulate? Now, the pattern is actually interesting because Python is doing something very implicit. It breaks its own rules here. It normally says, I would like to do explicit is better than implicit, but Python is breaking its own rules. And I'll show you what I mean. Self.x, actually, the init method also takes self, doesn't it? And in fact, actually, we won't bother running it. The init method is not where the object is created. There's actually this hidden method that's called new, and init just takes an object and mutates it in place. So we don't actually do the same thing in Rust. Rust is a little bit more particular. Firstly, we need to define our types. And this is the distinction between a static language and a dynamic language. Now, this isn't to do with object orientation. You can have dynamic languages that are functional, like Erlang, for example. But let's emulate this new this init thing. So we could create a actually, we'll start with just this. So we actually already have a default syntax, and that's let oh, sorry, crash 5 times. Okay, go away. That's a struct Rust. We actually want rectangle. Actually, and it's not actually a rectangle, is it? It's a point. We got our class point, and it takes x and y, and we have a structure point that has 2 floating point values of 32 bits each, and that now by default we actually get a constructor syntax, which kind of emulates, well, it kind of works in the same way as the init method in some sense. It is a little bit less flexible. In it, you can basically do anything. It's just Python. You can play around whatever you want. This literal syntax will just take the fields that you've defined and enable you to place an expression in there, which will evaluate to a number, which or evaluate to a value of this type. So if we wanted to play around just for fun, we can do whatever we want. We don't need literal values. We can have expressions in there too. But one thing we don't have is, so to start with, I want to point out that the method accessing and isn't so different than what we're used to. So one of the things I liked about say Python is that we can use these dot accessors and like dot methods. So, but actually I'm going ahead of myself. So we emulated this constructor pattern with the init methods just kind of by design or by default. With this literal syntax, that creates or initializes values. We don't need an explicit constructor within Rust. But you may have mentioned that I included the statement, well, this literal syntax is not quite as flexible. So what if I wanted to create something that is a little bit more flexible? Well, by convention, and by convention only, Rust programmers have this notion of a new method. Now, the term method sounds confusing because it sounds a lot like object orientation, and in many senses it is, because like a functional language would not allow, or doesn't really provide the facility to have methods that are attached like very, very innately to data. Now Rust actually is a little bit more willing to provide that for you. In this case though, we're not taking an implicit parameter self. But we're associating, we've got this impl which stands for implementation. We've got the ability to play around and do whatever we want. So actually maybe it's quite hard to think of a useful example for point, but maybe I have maybe I want to do some pre-processing. So I would like to assert that x is greater than 0, or at least is greater than -0, which is exactly which exists, by the way, in floating point. We want to say that it's a positive number, or greater than or equal to 0. Let's say we're only allowed, so we can provide these asserts. I'm just doing this for the sake of kind of, so this would be, what we're now trying to achieve is adding some constraints to the type. Let's say that we wanted to, in Python land, we might want to say that if is instance x, if not is instance, and we'd put, say, float, we would raise value error, type error. X must be a float. And like, note that, and we could check that, these must be numeric types. Let's say that we're pretty convinced of ourselves that actually must be the case. So we're doing a similar thing here. No, we're not. I'll pause that one for next. What we are doing, let's instance, I think that's the right spelling. We'll park that one very, very soon. Right now, we are doing if x is less than 0, raise a value error. Oh, it must be positive. We'll get to the type errors very soon. People who have used statically typed languages will know why I haven't included it in our snippet below. Actually, I'm just going to do this. This is kind of silly. It's like, you've come to a Rust coding stream. Why are you talking about Python? looks like your Python is longer than your Rust. What's up with that? It's both blur positive. Now, okay, great. Now, so we've got those, and so this new method is not baked into the language. It is purely part of Rust. The Rust community's tale of crabs and snakes. I love it. It's purely baked in to the conventions of the language. Now it turns out there's also kind of a shorthand, which means this syntax here will work. Now point, so we change all of this from this literal syntax on the bottom. You see that the editor now knows that there is there is a new method. It's actually not a method of an instance. It's kind of like a class method, but it's associated with a type. And it uses this double colon syntax, which is kind of inherited from C++. Now these should actually output exactly the same values. And they do. That's useful. I'm going to add the quiet flag because that will be a little bit simpler. Bang. Right. So cargo quiet run will compile this code main.rs and run it for us on our behalf. It turns out, by the way, if you've not used Rust before, that cargo has created a directory called target, and inside target is debug, and inside the debug subdirectory is our executable. So in this case it's called Rust oop. Because it happens to be the case that and so this executable is what is called by Rust, by cargo Rust. That's exactly the same thing. Okay, good. Now, so our first question is like, how do I emulate this pattern in Rust, which is like constructors? I've got an object that I want to initialize with some value. It turns out that we've decided that, or we've identified that Rust actually provides a literal syntax for creating instances of structs, in fact all types, but so it doesn't need it's actually, there's no requirement for a constructor. Like there's also no requirement for a destructor. We don't actually define, we are not required to define. There is actually a way to kind of get we can actually have deterministic semantics. We can opt in to defining our own constructor, but we don't need to. Rust will just Rust has very, very smart rules about how that works. Now, and we've talked a little bit about what is how to add kind of this this richer initialization. Let's say we want to do something complicated before we actually populate our values. Well, we can do so. Now Rust though is a statically typed language, so unlike Python, we don't need to check for types. It will be impossible for at any point for us to send in an integer to the function. Now this is going to sound very weird to someone who has used a dynamic language, because like this is very, like, it's a lot of bureaucracy. But sadly, it, like, I wonder if this works. Probably does not. Oh yeah, it does. Great. By the way, literals in Rust can include these type suffixes, and you can also include arbitrary underscores inside the inside your value. So we could also put an underscore here just to make it ridiculously difficult to read, but this is still 39.0. Now Notice though that we've introduced another type error, which is the mismatch between a 32-bit floating point and a 64-bit floating point. We would need to convert it, but let's just ignore all of that. So the thing that I wanted to point out was Rust is a statically typed language, which is actually a different distinction between object-oriented and more functional. In this sort of the spectrum of programming languages, Rust is kind of in this middle ground between object orientation and functional programming. Probably closer to functional in many of its the way that it operates. In particular, the next thing is actually I'll talk about it now because it's easy. So we've got question 1, how to and the question 2 is add constructors. Could you bump up the font size a little? Okay, yeah, sure, absolutely. Add constructors and complex behavior. Init time. Question 3 is, how do I mutate an object? I'm using the terminology object because it actually bleeds into Rust. Rust programmers actually happen to use the term object, even though it's not traditionally described as an object-oriented language. Now, let's say that I, for whatever reason, just wanted to say that the x coordinate, the x value in my inner point was now 1 as well. Rust is going to refuse to compile this, and the error that we receive is that point is not declared as mutable. And ignore the second thing as well. I've got the ability in my editor, if I just go Control 0, actually I'm just going to do one thing, which is screen. So hopefully people can see any. And I'm just going to do options. Sorry for doing this on the fly. And I want to search settings, and I'm going to do mode over here, and just this down to about 30. Keyboard shortcuts to. Okay, so now it should be a little bit less irritating for you. So if I do Control Shift, oh sorry, no, that's the wrong shortcut. Control dot, it says that I should consider changing this to be mutable. And to do that, I just add a mut keyword, which is, and so question 3, so to answer that, well, the answer is that all values, and I'm using immutable by default. They need to opt in. So you need to opt in to so that's one big distinction between Rust and Python or other object-oriented languages. Normally, and so this is very much on the functional side. The functional side will say that values are immutable and they shouldn't be touched. But Rust is happy for you to touch things. But watch this. Oh, actually, it's not going to work. It's not going to allow you for two writers to exist at exactly the same time. allow me to introduce a way that might happen. So I'm just going to say, like, plot a point. And I'm going to return nothing. So this is just a raw function. And, oh, sorry, I keep touching my microphone. That's now I'm just going to sort of do, let's just say I've got some other object, which is screen. Actually, I almost want to do this properly, but I'm not going to. Now, let's imagine that happens. And I've got another function over here, which actually says, what else could we do with a point? We could say translate. See, this should be as translation could be inside the object. And this one, these ones are just raw methods, or sort of bare functions. This one could just be. Actually, I'll just do scale. And I'm going to change the type signature to the oval. I'm going to say that point x is point x divided scalar, like probably multiply. That's if you've ever encountered the term scalar before, this is actually exactly why it's called scalar, because with vector mathematics you use scalar values to scale vectors. Yeah, so if you've ever done linear programming, sorry, not linear programming, linear algebra. Now, let's say that I want to scale my point by 10, and then I want to plot the point, and then I want to plot it again. Actually, I'm going to break it first by just plotting. We'll just plot. Now this will probably fail to compile. Oh, firstly, I've got some typos that I need to fix. That's not. If it does compile, I'll be very confused. And okay, so I need to fix those compiler warnings. Ah, great. This is exactly what I wanted to find. Now, oh, actually, that one is. Okay, so this is a really confusing part about Rust, is you very quickly get a situation where you're doing something with an object and suddenly everything blows up in your face. You can see here that actually I'm not touching plot. I'm not touching this point. It's actually doing nothing with it, and yet I introduce a compiler breakage. So if I remove this, and I go back and I try and run it again, I get X and Y. I'm just going to, I get some compiler warnings. I'm just going to silence those. I think that's it. Oh, dead code. Allow dead code. Allow some dead code. Yeah, that's fine. And I'm just also going to silence another compiler warning because we don't actually draw anything with our toDraw value. So it even knows that we don't even, the compiler in some sense is aware that we don't. Why does this not compile? And why does this? So I've just got this great comment in the chat, which is, the Rust's experience of both why does it compile and why does it not, and I think that's perfect. Because it matches my experience. So anyway, we now have we've got it back to where we want. If we uncomment this plot method, or it's actually a function, it will break. Now, what on earth is going on here? This is actually something that's very particular to Rust and not functional, but it will confuse you if you hey Moody, it's nice. Shit, now I'm under pressure. I applied, just so if anyone was confused, I applied to join this kind of really interesting, really fun live coder community, and Moody has been kind of like a bit of a mentor. And anyway, let's kind of move on. There is a so what we're trying to do here is explain why I broke my code. Now, I've got here this thing, value borrowed after move. Now we need to understand some jargon in Rustland that that a borrow is really a sort of a muddled metaphor, and so is move actually. So I've got two pieces of jargon that you're never introduced to if you've only used an object-oriented language with a garbage collector typically. Now, I need to explain two things to you. First of all, like there's this notion that you understand this kind of move semantics, and this other one is like, what is borrow semantics? Okay, so what is move semantics? So that's the first piece of jargon to understand. The move isn't actually about moving data around in memory. That's what I first thought. It's about more. It's kind of a higher level view about logically moving the responsibility for a particular value into a different scope. So you can think about when we initialize this PT value, so the PT variable, kind of point. The main function has responsibility for ensuring that point is cleaned up once the scope closes. So at the end of this function, all local variables will be removed from memory. Move semantics mean that the plot method we move responsibility into the plot method. So actually, when we get to the end of plot, which is, line 48 over here, to draw, or underscore to draw, is actually deleted as well. And so it actually no longer exists as a valid value when we get all the way down to line 57. It's not there. Are you limited face? Yes. I don't know Christopher Jonathan McKee. That's a very long name. I would hate to type that in if I needed to log in anywhere. I don't know what this means, but I'm gonna assume that it's a positive statement. By the way, I don't have anything flashing up. If you've clicked follow or subscribe, I really appreciate it. I think you're awesome, and my flare my streaming flare is still shit, so it's still there, so I will so please be with me. Anyway, let's carry on. How do we fix this? So the way to fix this is actually to say, as we kind of put in this magic ampersand and the magic ampersand says that I only want to borrow you, we use the term borrow. So what's borrowing semantics? So a borrow semantics is that I'm effectively going to lend plot access to this point, but main still has responsibility for deleting it when we get to the end of the scope. And it turns out that if you have a read-only borrow, which is denoted by this ampersand, happens to also be a reference, which also happens to be a pointer, if you've used C++. Don't be scared though. We're not actually forcing pointers upon you yet. If you have only used, sorry, if we have a read-only borrow, we can actually have two things running at the same time. So in fact, I could spawn a thread, and each of them could have access to point, and the compiler would be mostly happy. So we could sort of do something with point over here, and this could all live with, and they could all reference exactly the same memory, because by design it's impossible for any of those threads to ever modify the value. You'll never introduce a race condition in Rust code related to concurrency if you use the primitives that are available to you. There is a caveat there, which is if you kind of get into like the dark arts of Rust programming, there's this unsafe keyword, which basically allows you to break the rules. I'm not going to touch unsafe right now because well over 99.99% of Rust code in the wild does not use unsafe. And so I think it's not useful to discuss right now. I want you to know that if we have what is the reason for responsibility when we transfer function by the function by default? Okay, so that's a really, really good question that Moody has raised, and I will let's I just want to, before I answer it though, I just want to just make a distinction between a read-only borrow and a read-write borrow. And this is the ability for us to mutate. We've got this kind of mut keyword again, which is an ampersand mut, is a different type of borrow, which actually allows the scale function to modify the referent, the thing that is being referred to by the reference, and in fact it has exclusive ownership. Or sorry, ownership is the wrong term to use there. It has exclusive access to that data while scale is still in scope. And so there can only ever be one read-write access, and but at any given time. And there can also, but usefully, there can be like one n number of read-only references to data. This becomes very important. Right, so that's another really, really important question. So I'm just going to like drop this in the chat. Okay, so where was I? We can have like, we can have in read only references. Oh, no, they're just given this kind of jargon in Rustland because it means something to people that have experience with C++. There are analogies to some C, to kind of some C++ idioms as well. This is called a borrow as well. We can say mutable. Okay, so so Moody asked a really, really useful question. Does mut mean mutex or does it mean mutate? It means mutate exclusively. There's kind of a now I've actually never, but there is actually no mutex that's wrapped around point. There's nothing, if you decompile the binary that is created by Rust, there is no safeguards implemented inside the software. There's no locking, there's nothing there. Rust has guaranteed at compile time that there is so there's no lock, there's nothing like inside the structure. Like there's nothing at runtime that is slowing things down, but we can guarantee at compile time that there will only ever be one access to any data, or one mutable access at any given point along the lifetime of the entire program. That's because it happens to be the case that there is a quote unquote lifetime parameter. Now, can I hide? There is an ability for me to. I think I can remove unused parameter. Okay, that's not the action that I want. So, by the way, this should compile. I think it does. We haven't confirmed that yet. Okay, great. It compiles. Right. So yes, just to kind of confuse things again and just reiterate, mute or mut means mutation. It does not mean mutex. It happens to have the same semantics as a mutex, which is a mutually exclusive lock. A mutex though implies that there's kind of some runtime guard around, or it's kind of this this lock that exists at runtime, and you kind of need to toggle values and have a semaphore there or something. But there's none of that in the binary. There is no. Rust is very, very enthusiastic when it talks about there being zero cost abstractions, and its abstractions impose no runtime cost, or at least the abstractions that you the abstractions you kind of opt into runtime cost if you want more expressive code. Now there is one problem with the code that we've created, and that is what we actually want with our point values is probably we're used to something that looks a lot more like point.scale and have a scale method that takes 10. That would be much more idiomatic. Like this is, so on line 54, this is kind of like our target. So maybe question, what are we at to? Question 4. How do I create this syntax? Create, enable for my types. Okay, because having a function, so this is a very functional style. I've got a function that takes data and applies functionality to it. It happens to, it's kind of a blend, because an actual functional style would look something more like this. You would actually have to rebind the value, and but I'm going to ignore that for now. So we're kind of, let's say that. So what we want to do is create a method. So how do I do that? I haven't seen any empty languages in other languages. How does that actually work? Okay, so that's a I just had a really good question. I'm just going to park there though. I want to talk about creating a method. Question 4, how do I enable the syntax to my types? What I do, I've got this impl block. So by the way, if you've just joined our stream, struct.point has, like, it's the barest point type that you can create. I create the structure, which is analogous in some sense to the class keyword, and x and y. Now, I need a separate block. Unlike Python, say, it's not all, in fact, most object-oriented languages, they are kind of disjoint. I've got the implementations, and I can create my method up here. Now, I actually need to replace point.t with self. And self becomes a... Oh, I need a mutable... I don't need the type in there. I mutable access to self. And then I space all of this stuff. In fact, I can shorten it down as well by using the assign multiply operator. Shorten the code. He says, oh, except that's something else. By the way, this is something else I just want to point out very quickly about Rust, which I really like, is that if you've got a typo, Rust will refuse to compile it. Like, it's impossible to do that. It's impossible to kind of get the order wrong, and so this is, I want to multiply and then reassign the value. Now, if I was to run this in Python, it would probably use assignment and then the multiplication and just kind of do it. And but Rust is not going to allow me to do that. Another way, by the way, just for fun, I'm going to show. Let's say that I want to compare x and y. For some reason, I've got scale. I want the scalar to be. I'll assert that the scalar is actually. Let's say that I wanted to test that it was. What I'm actually doing is I'm saying that it can only scale positively. It must be more than 0. Well, actually, greater than equal. Now it turns out that this will compile. This is fine. But let's say that I had a typo in in Python land, and I just inadvertently assigned scalar to 0. It happens if there was an assert statement that it would evaluate to false by the fact that 0 evaluates to false, but let's ignore that for now. Python would be happy for us to just kind of add an assignment where I meant to use an equals or some other operator. Now, Rust will prohibit you from doing that anywhere. And like for me, that's enough of a reason to use Rust that I strongly encourage people to investigate this language because it's so good at being able to be better, like being very to enable you to write better code and take the frustration away from runtime errors. I have become so irritated with other languages that allow me to break, like to create, like it's frustrating that the compiler is pedantic, but also it's just so liberating, and I thoroughly enjoy working with the Rust. Okay, right. So now we've got through question 4. Now I've just had a question from the chat, which is, in fact, there's 2. So Moody at 11 o'clock, 11:02 said, "What is the reason for object responsibility being transferred into a function by default?" Now, very quickly, he's talking about the fact that I initially created plot. I'm just going to say plot 1. Or plot, yeah, we'll just say 1, 2, 3. Now, these are the same, in some sense, the same types, but they've got these kind of different prefixes. Now, it turns, and almost always, you're dealing with versions 2 and 3. Because this says that you are, this plot 2 says I want a read-only reference, and for something which draws you to the screen. That makes sense. Now, if I want to be able to mutate in place, I add like a mutable reference. Now, plot, this up here is actually transferring ownership. I guess the reason, and so probably a smarter way to do it, and probably a way that if I were to design a language, this mutable borrow would be first, is that the plot 3 is kind of what you want by default most of the time, but actually Rust's designers decided that this is, I'm going to introduce some more jargon, so my apologies, but if you have kind of an undecorated type, like we don't have these reference decorations, that should actually represent the type itself, and so that's kind of like copy by value, like call by value, and so that makes sense to just say that. But actually, we want to be explicit, and so for these two, plot 2 and plot 3, in the binary, you're not actually, the call site inside is not actually receiving a value of point. They're receiving a pointer, and it just happens to be the case that there's different semantics. And I think what we're trying to do, the language designers decided to say that even though this is the one that you use the least, we're going to impose some more syntax on programmers because we want to be very clear about what every function does. And it turns out that this is only confusing. It's like one of those things when you're learning a language, like, natural language or programming language. It kind of feels strange at first because it's not familiar. But once you've been there for a while, and it makes it actually it becomes easy to read. So I can definitely see why it's difficult, but okay, so plot no longer resist. Okay, so just going to double check that we compile again. Oh, I removed that. So it's saying, by the way, this compiler error is saying that the function actually wanted the value, but actually I was only giving it the pointer. So I'm just going to fix all of that. Okay, now I've got x10 and y0. So I've just had a really I feel bad for Cog Doctor because they have asked me a really important question, which is like, how do I do like, what's this bar? There's a particular syntax for anonymous functions or lambda functions in Rust that I want to address, but also Moody's got a really good point. Now, why is a GC at the end of the function when it was declared in another scope? So earlier on, I said that that if you have a function of this type, an argument, this sends ownership from main into plot. At the end of the scope, we call this in Rustland we use the terminology drop. Now, what is drop? We dispose a drop is like it's destruction. It just happens to be inside the drop trait, but it's possible to manually do that, and there is one distinction though. So this is what. So in some sense, Rust is kind of automatically injecting a call into drop at the end of any local values. So I could just say, like, I just create a local value, a local variable. A is 1, 2, 4, 5. And what's also happening at the end of the scope is that we're also dropping a and to draw. And I believe that the sequence is actually inverted. Yeah, so that way. Just 1 second. My 2-year-old has just decided to ask me a question. So I'm just going to go very, 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 very quickly to an ad break and sort her out. I hope that this won't be too much of a distraction. She's normally really good when I'm on the computer, but now it sounds like she's going to cause havoc. So I would introduce you to her, but I will try to she's pretty convinced that she wants to do drawing with me, so I just need to sort her out. 1 second. I will be right back. Hey, I apologize. Thanks very much for everyone's messages. It's okay, sweetie. I'll see you soon. So if you've just joined me because you're popping into the chat this time, I just had a just had a 2-year-old decide to play. Now let's talk about Rust. Okay, so there is a we've got these two. So this is what the Rust compiler does by default. It at the end of scope will try and clean up any values that exist. There's actually kind of this really kind of fun Rust idiom. It turns out that this is defined by the compiler, and I would like to show you the default implementation of drop, because if you happen to notice that the definition of drop says it does so by calling the argument's implementation of the drop. So what on earth is drop? Well, it turns out that this is a known as a trait, which you can think of as an abstract base class if you have used lots of object orientation. Now, the really neat thing, and I've just pulled up the standard libraries documentation, the really neat thing about drop is how it's implemented inside the source code. And I'm sorry for this, by the way. It turns out that it's not implemented. That's actually just the trait implementation. And it's fun. It's Mama. I need to help out with the music blocks. It's okay, sweetheart. Okay. So where's drop? I shouldn't really talk about drop, but it's fun. Oops, that's the wrong button. Anyway, sorry for distracting myself. It turns out the implementation for drop is it's just an empty function. Can't find it right now, so I'll get back to the task at hand. Like literally, to implement drop is to do this. So it turns out that the compiler does clean things up, and okay. Now, but if so you can definitely implement yourself. So one of the other questions. So the important thing to note is that Rust does not impose a garbage collector. There is no garbage collector running. You can also and so your program will execute as fast as it's able. You can also implement, you can overwrite the implementation of drop such that it doesn't actually release the memory back to the operating system, and you can effectively have a function, like you can always leak memory and it will just run as fast as you can, and that might be useful for like a command line utility that is just going to be like a one shot and you want it to run as fast as possible but hundreds of thousands of times, for example, or something. Now let's carry on with learning a little bit more about Rust. So I think there was one more question in the chat, and one of the questions was this thing about, I haven't seen empty lambda in other languages. How does that actually work? So I'm just going to pull that from the chat. And so the Cog Doctor, I hope you're still in the audience. This one's for you. I haven't seen empty lambda in other languages. How does that actually work? Okay. Right. So this one wasn't something that I planned to talk about, but let's talk about it. Now let's say that I have an array of points. Like, now, what does that mean? I'm just going to have to create them, I think. I'm going to declutter this main method. Oh, oops. And so just a question for anyone, do you know what a lambda function is? Because if you don't, this next little section is going to be slightly confusing. Just in case you're too shy, an anonymous function is a function that doesn't actually have a name. That's all it is. It turns out that these are useful in Rustland. Now, it's just one line, and I'm going to put 5 points on the line. And just we can imagine a line being, if you were drawing with turtle graphics and you wanted to start at a point and then kind of draw a line, that's what we're conceptually. Now this is the syntax. It's less ergonomic than, say, a Python or Java. Most dynamic language, Ruby, Perl, if you want to play with Perl. Let's say that we start X and we're just kind of drawing we're starting at the origin and we're up towards the right. Leave this back 3 points will be. So this is just a 45-degree. If anyone wants to do calculus or please don't distract me, because I'll probably try and do that too. To answer that question, that was useful. I'm going to retain. Actually, I'm going to delete these as well. So I've got my line, and vector is actually, I'm going to change the syntax because this is slightly confusing. Or it's just a I think that's right. I wonder if this will compile. And I'm also just going to add a little bit of sugar. I can ask the compiler to actually write some code for me. And I do that with these kind of derive macros. And I'm going to in particular derive the debug row. Debug trait. And think of a trait as an abstract base class. By the way, I've just noticed that a couple of people have followed me. I really appreciate it. It's great to see. It's great to have you on board. I try and stream at least once a week at about this time. So it'll be awesome to see you again in the future. I also am trying to find, I'm always interested in topics and so forth. And so if you have any suggestions, please just ask. And I can use this kind of obscure syntax to actually print out line. Let's see if this will work. Oh, now it's confused. Okay, let's go. And now it's a little bit happier. Couldn't you do an intro to Python? Absolutely. 100% I can talk about Python. I wonder if I have a Python emote. Probably not. Maybe I should get one. I'm stopping because I'm trying to hunt like madly through a list of emotes, which is just a silly thing to do. I'm just gonna give you a stupid face. Like I'm just not gonna do that. I'm just gonna be like, are you Moody? That's a great question. Well, by the way, I should also put my book. I'm really bad at promoting my own stuff, by the way. So I'm just going to do a... Actually, no, I'm not going to do that. I'll pump the book, shall I? Because there are some people who are interested. Now, I have got this. I am in some, not in some sense. I'm a published author in Rust. Even that's one of my claims to fame. In fact, I have written an introduction for Rust specifically for people who have started their programming journey with dynamic languages like Python and Ruby, JavaScript, and want to know more about systems programming. And it has received ridiculously good reviews, and I would thoroughly recommend that if you've got $20 to get it, and if you don't have $20, to find someone else who wants to. We're gonna do it here because actually there's some reason the comments don't come up in Firefox. Right? I'll stop pumping the book soon, but I'm really proud of it. And there's this thing of like, is it done? And I'm currently working with a university professor to do. We're going through like an extra technical review, and so it looks like it's $50. It turns out though that often Manning will have it available for cheap, and if you are interested, I've got a code already. I'm so terrible at otherwise you can just buy two things. If you've got some friends, you can join up and like buy it together is probably my suggestion if you want to save even more money. But I've also got a code for you for people. Discount code. There we go. Okay, good. Okay, stop with the book. So thanks, Moody, for mentioning that, by the way. Right, now, let's go back to talking about Rust. There was a reason why I wanted to introduce a collection, and I'm struggling to remember. Oh, Lambdas. And that's because we're going to apply some functional styles to some functional programming idioms, and try and kind of see how they map to Rust, and how, if you're more familiar with object orientation, we can go we can use either style. Here we go. That's what I meant. Oh, actually, I'm just going to do something that I know will break. Let's say that our points are not large enough, so we want to scale them by 10. Let's forget 10. Let's scale them up by 100. Oh, we get an error. Okay, so we get this horrible problem, which is a value borrowed here after move. But I'm like, surely you know Rust, that, like, dear Rust compiler, you know what I'm trying to do. You can see that I'm never accessing things again. Sadly, Rust is going to be really pedantic and say, no, Tim, you need to follow the rules. And the rules are that if you don't take a reference, you get the value, and you can only use it once, because at the end of the scope, and it turns out that the scope has changed from main to inside this scope that I've just selected between 62 and 64, that is when I drop the value. So the consequence of using a bare value right now is that Rust gets very upset about an attempt to reuse line later on. So we can. This will actually work if I just remove the print line. Or it says. Oh, it turns out that it doesn't. This will work, but actually I can't do anything with it. So there's no point in me removing a later reference to line. Rust is going to try to be extremely particular, and it's going to be really pedantic, and it's quite annoying if you are new. Yes, yeah, like Moody's raised a really good point, which is that, like, if this counted, like, if this is the kind of thing that tripped you up, like, late at night, you just like want to punch yourself. Turns out though that if you were plotting this on the like on a number line or something, it would visually look exactly the same, but we've just increased the scale by 100. We could have done some other transformation that would have been much more interesting. But there you go. Well, linear transformations, where it's at. Okay. So this is kind of an object-oriented style. Now, Rust supports a different programming style, and I'm finally getting to a question 40 minutes after it was asked, which is like, can you explain this? Oopsie. This weird syntax that I've been seeing, which is kind of this bar syntax. What on earth is going on there? And it turns out there's a problem, he says. I'm hopeful that actually, see, that's the wrong thing. I'm hopeful that it's going to work. So notice these two styles create exactly the same output, and this is one instance in which Rust's like support has, it kind of feels, the Rust, idiomatic Rust is to use functional programming, like something that looks much more functional. We take a higher order method, which takes a point going along, and we map it. We apply that function multiple times in quite a declarative style. And that's confusing. I wonder why that didn't work. I'm sure I introduced a typo somehow. What on earth? That's super confusing. I will try and figure this out. Okay, so now I've got, okay, what on earth has happened here? Not satisfied. Oh, maybe I need to think. I need to. Sorry for the confusion. The error exists, but the transfers are not satisfied. Huh. Now, oh, okay, so that's a different problem. Oh gosh, I'm really confused now. This doesn't sorry. I'm gonna get back to my point, which is that we've got two styles, and I really want to know why this won't work. Okay, I need to pass. So what on earth is going on with this with point value with a anonymous function? So I could create a closure, which takes a point, and this could be and then I could do line sorts. I'm sure that there is I'm sure it just worked. Why has it stopped working? That's the weirdest thing I've ever encountered. There is a reason that I'm oh well. Not today. Sorry, I shouldn't. I'm getting super confused. We can apply either style. So what is this? This bar is what's formerly known as a closure, and it's a form of function that allows us to take it encloses its local environment, and in some sense it's an anonymous oh gosh, I'm just really frazzled by this. Hey, by this problem that I've just encountered. Let's say that I've got this thing which is like add and this double bar is saying that this is a function that takes no arguments, but it happens to also add a new point to this line that we've created, and we'll put it 5, 5. Is it a nice place? Maybe I'll just put it at the origin. Now, how do I call add new? Turns out that I don't think that I can just kind of randomly call it. Like, will this run? Probably not. Cannot borrow, add new point is mutable, is not clear to... Actually, it turns out that the function wants to be mutable. That's weird. Or maybe I can just call it. Oh, okay, so that works fine. It's just a convenient way of creating functions. It happens to be the case that this particular syntax, and so its type, by the way, is actually this double bar arrow, like, and then we return what's known as the unit type. So that's kind of like the most obscure syntax, and would be ridiculously intimidating for a program for like a beginner Rust programmer. But I've introduced it here because we're trying to answer this question of like what is a Lambda function in Rust, and this is a Lambda function in Rust. It turns out that or an anonymous function as another term. We've created a we have bound an anonymous function to Rust, to this variable add point, and we can call it multiple times, and we can grow we can grow this line. Okay, great. Now I've got 15 minutes left on the clock, so I thought now I've got a couple of things that I wanted to chat about, and one was abstraction and the other was inheritance. Sorry, abstraction, not encapsulation, and that might be like getters and setters, maybe. If that's interesting, I'm happy. I'll just carry on with those kinds of things, or I can receive questions. If you have a question, just ask it in the chat, and we'll try and get to it. Right, okay, so now the question, or the thing that I'm trying to attempt now is like, is there, oh yeah, no, that's all good. I hopefully I answered that question. I know that it was very late. I did ask you to wait 2 minutes and you asked it for like nearly 45. Sorry, it was a bit of a muddled answer. I have, so let's go back to creating this value, creating this this type. So struct point is analogous to say class point. Now, to be very, if I was in Java land, I would probably not ever allow people, like I wouldn't allow like public access to my, I wouldn't allow like accessing by I'd add a getter. So how do I add getters? There is actually a like third party, there's nothing built into the language for automatically like auto-generating. It wouldn't be, first of all, it's an underscore based language. So the way to create an accessor or like a getter method would be to do this. Now, I'm only doing it if you are disgusted by the idea of an accessor value. I want you to know that that I agree, but also there are lots of people that that prefer, like, are familiar with this method of creating. I'll just create one point. Sorry for mucking people around. I'll get to the point soon. I've got a get x and a set x, so I've got my getter and my setter. I'm just going to go back to a single point rather than a vector of points, and because in object-oriented languages, there's kind of this dogma that you never kind of allow people to have raw access to any of your attributes. I find that, and the idea is that you're encapsulating hidden information, and so you shouldn't like expose the internals of your implementation to the outside, and everything should be through the interface. So now if we wanted to change x from up here, and we thought that actually we would have it as let's say that I don't know, I find that I don't necessarily agree with this dogma, but let's say that we wanted to remove the field x and just turn this into we wanted to return x, and we always wanted to just say get x was some other method call. Turns out that it's a dynamic thing, so that we had a subclass which was like get sensor value. So you can think of like this get sensor value as like a subclass of point that actually like dynamically creates points, or like it creates its position, rather than having them sort of statically inside a structure, or like inside the data. Now, this is very un-idiomatic Rust, in my view, anyway. Getters and setters don't really exist, so not in the same way. So to do it, if so what am I doing? What am I talking about? So this is kind of like if I was from Java land, this would be pretty close to what you might see in Java. You might see get, except it would be like camel case. But here we have got. But if you're in a situation where you need a getter, and we want to provide it in a method, we want to provide it in a method, you would often omit the get. So there are some instances where people add getters to their fields, but you'll often see them just as the field name, and then that will be a method call. And you could, so this is slightly more idiomatic. It's still kind of odd, I think, in Rust, because Rust is so particular about the use and reuse of data that make sure that, and so we ensure that it's safe, that we can't accidentally overwrite a value. A, because we're the wrong type, and B, because we don't have mutable access. We need to actually annotate our points. There is something though that we might want to do, is create a situation where some of our data is generated on the fly. Like we're actually literally like checking the, let's create, I've got 8 minutes, so I want to create 3 different types of points. One will be like a random number generator that just kind of randomly jumps around. Another one will just be kind of this, what we've already got. And then maybe a third one is like picking values from a sensor. Actually, that can be the random one. Maybe we'll just do. So inside my COML definition, so this is like this cargo.toml thing is a is like a description. If you've used Python, it's kind of like requirement.txt and setup.py. If you Javaland, it's like a Maven file, and use rand. And what do I do if I want to create 2 classes that implement the same behavior? So this is kind of one of the problems that we can actually solve in Rust. And now Rust has this notion of a trait, and now the terminology trait is a bit obscure, but I want you to kind of bear with me for a second. I just want you to accept that it's strange. I'm going to rename it to fixed point, maybe static, because what I mean is data point. Oh, that's not right. Actually, I'll just because I want to create a trait that is, my trait can be coordinate. And it can be the term trait, think of it as abstract base class. And I'm just going to use the I'm just going to use static types. There is the ability for me to use a type variable, in fact, but I'm not going to bother. Now let's say that I want to, I've got this abstract base class coordinate, and let's say I want to create a virtual, no, I want to create a concrete type. So what I need to do is implement coordinate for point. Now you can see here that, oh, actually you can't. Function X has come up, and I will I then have the ability, actually I'll just do it the ugly way. Get X, and there I get a type error because I'm saying that I'm still missing part of the interface. Function, I want to do Y, and I'll just do self.y because I haven't implemented that getter. Now I've implemented the and I'm just going to change something else, which actually I want to be able to draw or do something with points, and in fact I'm going to change this to say that I want to be able to draw anything that is a coordinate, rather than just a a fixed type, or like a one single type. I want to be able to have anything that can implement the coordinate trait. And I do this with introducing a slightly different syntax, which is I take a reference to a trait or an abstract base class that is dynamically, this is just a marker to say that this is a particular, like this is a particular way of doing it, that it happens at runtime, that I don't care where like what concrete type is actually being used. I'm just going to do X, and then actually I'll actually use this thing, and my drawing will be will be to actually invoke it. This way we're not going to get any issues. Okay, so plotting will draw X and Y to the console. Now I want to be able, I said that I would also create a random number, like something that dynamically generates values on the fly. Now let's do that. First, so I'll just put this point and just double check that it compiles as is. So just with this one type, and I'll go run. It's taking a while. Probably because it needed to go and import, it's saying we've got this import this random thing. So I've got this compiler warning that I'll take that out of scope. We don't get compiler warnings. We're happy though that we've actually been able to remove point from the arguments, like from the type, and actually we're now able to accept anything that implements coordinate. So anything that implements the interface defined by this abstract base class is the terminology that I would use if I was in object orientation. Now, just for people who have used Rust before, the terminology to hunt for, if you want to investigate this in more detail, is that ampersand dyn or din is known as a trait object. And that's all I want to say about trait objects. Is that, actually, no, it's not all I want to say. What they are is another reference, and that the actual function pointer or the method that's invoked is actually determined at runtime depending on the type that actually exists. The compiler is unaware of the actual concrete type at compile time, so it actually introduces a tiny fractional a minuscule nanosecond level slowdown because it needs to look up the actual. So let's say that I want to create a different struct, and my new struct is actually going to have no data at all. So this is a random point. This is known as a zero-sized type, and a zero-sized type actually disappears inside in the binary itself, which is a bit of a weird thing to think about. But it only exists at compile time. It does not exist at runtime. So we can still implement we can still implement coordinate. If we wanted to, we could actually, thinking about this now, if I was to do the for real, I'd probably maybe keep the seed, or because at the moment I need to do a thread RNG, which stands for the local threads random number generator, and then I need to call gen, I believe. Actually, I'm just going to just do RNG. So that's an RNG. Maybe I need to import a type, sorry, a trait. Yeah, there's this prelude thing that I need to include, and that will, actually this is going to simplify. I think I actually get access to a random method, but I don't need to worry actually instantiating a random number, because all I care about is this random, which is useful because it happens to be a point between 0 and 1. Random. Turns out that that's x and y is the same, and in fact I may as well just call x. This is a, because by the way, because it's just it itself kind of defers to random, so this is an example of me creating a like an encapsulated it's me creating encapsulation via trait, and which kind of simulates inheritance without actually requiring inheritance to be in the language, which kind of is a kind of a mind-bending thought, but this works. Yay! Hooray! What we've got here is we've created an interface and instantiated it twice, and kind of created something that feels a lot like inheritance without actually requiring inheritance to exist. It turns out that I've still got a compiler warning, so I'll just get rid of that as well. And usefully, the values that are generated are completely random, and I'm happy. Woohoo! Okay, so thus ends my stream. And so I will I'll hang up here. It's been really nice to hang out again, and yeah, have a wonderful day. I'll see you guys later.